All right, in this class, we're going to be looking at balancing of chemical equation using neutralization reaction. The question you ask yourself is, what is a neutralization reaction? Neutralization reaction, as the name implies, is a reaction involving an acid and a base to form salt and water. And in some cases, carbon dioxide is also one of the products formed during neutralization reaction. Now, let's take a look at a common example of a neutralization reaction and how we can balance the chemical equation involving neutralization reaction of sodium hydroxide and tetraoxosulfate 6 acid. Now I said the neutralization reaction between sodium hydroxide and tetraoxosulfate 6 acid produces salt and water. Write a balanced chemical equation for the reaction. Okay, now for us to have this, for us to write the balanced chemical equation for this reaction, it is very simple, provided we can write the correct chemical formula of the different substances, both the reactants and the product. Then we can now balance the equation as follows. So we have sodium hydroxide as one of our reactants. So sodium hydroxide can be written as NaOH. Okay, so that is the correct formula of sodium hydroxide. Then we have tetraoxosulfate 6 acid is written as H2SO4. Okay, then we have products. These are the reactants, the sodium hydroxide and tetraoxosulfate 6 as reactants. Now, on the product side, we have sodium tetraoxosulfate 6. Okay, we have water and sodium tetraoxosulfate 6. We have sodium tetraoxosulfate 6, which is Na2SO4 as the correct formula. Then we have water as part of the product. So water is H2O. So these are the reactants and the product. The next thing we do is to write the chemical equation. So we have sodium hydroxide is NaOH. Of course, it is an aqueous solution, plus we have our H2SO4 aqueous to produce Na2SO4 aqueous plus H2O liquid. So these are our reactants and the product. So sodium hydroxide reacting with tetraoxosulfate 6 to produce sodium tetraoxosulfate 6 and water. Now, taking a look at compound by compound, we start with the simplest compound here, which is sodium hydroxide. Now here, our sodium is, on my left hand side, is made up of 1 atom, while my right hand side, it is 2 atoms. So for me to balance the number of sodium atoms, I'll simply introduce 2 moles of sodium hydroxide to my left hand side. So I will write 2 moles of sodium hydroxide to my left hand side. So my new equation will now have something of this form to produce Na2SO4 aqueous plus H2O liquid. Okay, so this is my new equation of reaction. Now taking a look at this, I have 2 moles of sodium at my left hand side and my right hand side is 2 atoms of sodium. So the sodium is now balanced. Now next I will look at is the next element to be balanced. My hydrogen at my left hand side is already 4, my right hand side is 2. So in trying to balance the hydrogen, I'll simply introduce 2 moles of water to my right hand side to balance the hydrogen as 4. So this will now give me 2Na OH aqueous plus H2SO4 aqueous to produce Na2SO4 aqueous plus 2H2O liquid. Okay, so this is my new equation of reaction. So I can now see the number of hydrogen atoms at my right hand side is now 4. My left hand side is also 4. So taking a look at all the elements by element, I have sulfur. My right hand side is 1 atom. My left hand side is also 1 atom. Oxygen at my left hand side is 6 atoms. My right hand side is also 6 atoms. So this is a balanced chemical equation for the neutralization of sodium hydroxide and tetraoxosulfate 6 acid to produce sodium tetraoxosulfate 6 and water. So let's look at our last question on neutralization reaction. It says sodium trioxocarbonate 4 reacts with hydrochloric acid. This reaction is termed neutralization. Write the balanced chemical equation for the reaction. So my required equation of reaction here is sodium trioxocarbonate 4 is Na2CO3 aqueous plus hydrochloric acid is HCl also aqueous to produce NaCl aqueous plus CO2 gas plus water. Okay, so because we said some neutralization reaction may lead also to the formation of what, or to the production of carbon 4 oxide, just as we have in this case. Okay, now taking a look at the equation, we see that we have 2 atoms of sodium at my left hand side. My right hand side I have 1 atom of sodium. So for me to balance the number of sodium, I'll simply introduce 2 moles of sodium chloride to my right hand side. So I will now have Na2CO3 aqueous plus HCl aqueous. So give me 2NaCl aqueous plus CO2 gas plus H2O liquid. Okay, so this is now my equation, my resultant equation when I added 2 moles of sodium chloride to my right hand side. Now by doing that, I have now seen that my number of sodium at my left hand side is 2, my right hand side is also 2. Also, my number of chlorine at my right hand side has increased to 2, while at the left hand side it is 1. So for me to balance the number of chlorine, I will simply introduce 2 moles of HCl to my left hand side. So I will now have this as my next equation. So I will have Na2CO3 aqueous plus 2HCl aqueous to give me 2NaCl aqueous plus CO2 gas plus H2O liquid. So taking a look at this equation, I have 2 moles of chlorine at my left hand side, 2 moles of chlorine at my right hand side, 2 moles of hydrogen at my left hand side, 2 atoms of hydrogen to my right hand side, while my carbon is 1 at my left hand side, carbon is 1 also at the right hand side. The oxygen is 3 atoms at my right hand side, my left hand side is also 3 atoms. So with that, I have balanced all the elements and atoms in the equation. So that is a balanced chemical equation for the neutralization reaction between sodium triisocarbonate 4 and hydrochloric acid to give me sodium chloride, carbon 4 oxide and water. So with this, we'll come to the end of balancing of simple chemical equations. But I urge you to join us in our next class as we talk about some simple calculations involving chemical equations. Hope to see you in that class. Bye for now.